I did say that I was going to make a video about question 21, and here it is. Okay, it says the decibel level of the sounds produced by a trumpet is 80 decibel at a distance of 5 meter. What is the decibel level of these sound waves at a distance of 50 meter? Guys, the way to solve this question, very easy. Don't overthink it. Okay, so first of all, you look at it and you're given the decibel level, right? And you're like, okay, but like from this rule that we've got over here, okay, there is no relation between the radius and the decibel level. So what is this asking for? What does this want me to do? All right, so, well, obviously, there is no radius in this equation, okay? But there are, well, now I'll talk about it. Hold up. So I look at it, I'm like, don't exist. It's probably about something else. All right, guys, we know that intensity, we've studied in like the, I feel like is the, I feel like it's the beginning of 4.2. Yeah, section 4.2 is in the beginning. We talked about this rule. Okay, intensity equals to power over 4 pi r squared. Well, this is the area, this is the surface area of the spherical waves. All right, and sound waves are spherical. Basically, how I go about solving this is that, first of all, I have to find this intensity, okay? Now, guys, if you look at this equation, and if I want to find, okay, what's the intensity for, what's the intensity when I change the radius to 50 meters, okay? From 5 to 50. Well, you cannot take that relationship. You cannot find the I. Why? Because the P is missing. You gotta find the P first. But how can you find the P first? All right, so we'll tackle that, don't worry. So basically, I went ahead and I substituted this 80 into the relative decibel level here, relative intensity, equals to 10 log intensity over threshold of hearing being 10 to the power of negative 12 watt per meter. Plug in everything, solve for I. By the way, the fact that everything is solved for is because I made a video and I deleted the video because I wouldn't get the answer, and turns out this whole time I had been regarding the distance, which is 50 here, as 25, and obviously I wouldn't get the answer. But yeah, that's why it didn't work, and that's why everything is written down. So we solve for I. 80 equals to 10 log I divided by 10 to the power of negative 12. Solve for I, and then basically divide both sides by 10. 8 equals to log I over 10 to the power of negative 12. Both sides raised to the power of have the base of 10, because how to remove the log, we need a 10. So 8 to the power of 10 to the power of 8 equals to log times divided by 10 to the power of negative 12. Solve for I, multiply these two, you get that answer, which is 10 to the power of negative 4. Okay, now what you do is you plug this, that you found, this intensity that you just found, into here, and then you find the power. Guys, the power will not change. The power must not change. Why? Because when you are asked to find the relationship between intensity and the radius, the other quantities that are in the equation, they have to be constant, because we cannot take the relationship between intensity and radius when our power is not constant. That's just not how it works, common sense, I'm afraid. So we find the power equals to 0.0314 watt, and then we plug this, or you could take the whole number, I don't mind, into this equation, but instead of radius being 5, we pick 50. Let's try it. Okay, so hold on. So let me just find the power first so I can just, plug it in there. 4 times pi times 25. Power found. Okay, now here, power divided by 4 pi times 50 squared. Actually, don't round it, guys. Don't round it. Just use the whole power thingy. Use this, okay? Confused time. Hold on. Or do that, okay? And then do it. The answer should be 10 to the power of -6. Now, we found the intensity. Go ahead, 10 to the power of -6. Let's copy that. What happened? Okay, copied that. And then plug it into the relative intensity equation, which says 10 log. Do you know what? Actually, never mind. Let me just. Do you know what to do? Switch their places, okay? Because this is a negative, it's supposed to be up there, and this is a negative, it's supposed to be down there. So it's like 10 log. You don't need calculator for everything. Just save time. So 10 to the power of 12, 10 to the power of 6, 10 to the power of 6, 10 times 6, 60 dB. There you go. That's the answer. Bye.